Close to the Sun, a tiny planet hides big secrets. Mercury, small and hot, fooled us for years. But now, space robots have uncovered weird surprises. They claim to have found diamonds on the hottest planet. And that's just the start. Mercury's insides are all wrong. Too big, too strange. Why is it so different from other planets? And what else is Mercury hiding? Mercury, the smallest planet in our solar system, has fascinated astronomers and space enthusiasts alike. Its mysterious landscape, hidden from view for centuries, began to reveal its secrets only with significant advances in space exploration. The journey to uncover Mercury's enigmatic terrain started with NASA's Mariner 10 mission in 1973 and continued with the Messenger probe in 2004. Mariner 10 was the first spacecraft to visit Mercury, giving us our first close-up glimpse of this elusive world. During its flybys, it captured images showing a landscape riddled with craters and strange ridges, much like our moon. This mission revealed that Mercury had a rough, heavily cratered exterior, a surprisingly strong magnetic field, and a larger core than expected. These discoveries challenged previous assumptions about Mercury's composition. The Messenger mission, which launched 31 years after Mariner 10, took our understanding of Mercury to new heights. Unlike its predecessor, Messenger was designed to enter orbit around Mercury, allowing for a more comprehensive study of the planet. During its mission, Messenger took an impressive 200,000 photographs, revealing areas of Mercury never seen before. One intriguing finding from Messenger was the discovery of unusually high levels of calcium and magnesium on Mercury's darker side. This raised questions about the processes that could lead to such concentrations. Additionally, the mission found that Mercury's magnetic field was unusually strong in the northern areas, which was unexpected compared to other planets. These discoveries led scientists to realize that Mercury's internal structure and formation process were quite different from what they had initially thought. On most planets, like Earth, magnetic fields are generated by the movement of liquid iron in the core. However, Mercury's unique internal structure results in different magnetic behavior. But what makes Mercury's terrain truly stand out? It's not just the craters and ridges, but also the extreme conditions on its surface. During the day, temperatures can reach a scorching 430 degrees Celsius 806 degrees Fahrenheit, hot enough to melt lead. At night, they plummet to a frigid minus 180 degrees Celsius minus 292 degrees Fahrenheit. This extreme temperature swing is due to Mercury's thin exosphere, which does little to regulate temperature or retain heat. Despite these harsh conditions, recent studies have uncovered some surprising features on Mercury's surface. In 2012, Messenger data revealed evidence of volcanic activity on Mercury, including pyroclastic deposits from explosive volcanism. This discovery challenged the long-held belief that Mercury was geologically dead. Even more intriguingly, in 2020, scientists announced the discovery of water ice in some of Mercury's polar craters. These permanently shadowed regions are cold enough to preserve water ice, even on a planet so close to the Sun. This finding has sparked new questions about the potential for simple forms of life on Mercury. Could there be extremophiles, similar to those found in harsh environments on Earth, living in these icy refuges? The most recent mission to Mercury, Bepi-Colombo, launched in 2018 as a joint effort between the European Space Agency and the Japan Aerospace Exploration Agency, is set to arrive at Mercury in 2025. This mission promises to provide even more detailed information about Mercury's surface, including its chemical composition and geological history. From its unexpectedly strong magnetic field to the presence of water ice, Mercury continues to surprise us. But what we're about to explore next will really make you do a double take. How does a planet so close to the Sun manage to have a year shorter than its day? A year shorter than a day. When we think about planets, we usually imagine them spinning on their axis once a day and orbiting the Sun over the course of a year. But Mercury breaks this mold in a fascinating way. On this small, sun-scorched world, a year is actually shorter than a day. Mercury takes just 88 Earth days to complete one orbit around the Sun. This rapid journey makes a Mercurian year much shorter than ours. However, a single day on Mercury, a full rotation on its axis, takes a whopping 176 Earth days. This means that on Mercury, a year is only half as long as a day. This unusual situation creates some truly bizarre effects. If you were standing on Mercury's surface, you'd see the sun rise, then gradually grow larger in the sky as it slowly moves across the heavens. At some point, the sun would appear to stop, then move backwards for a while, before resuming its original direction. This strange dance happens because Mercury's rotation can't keep up with its speedy orbit. Scientists believe this slow rotation is due to tidal locking. Over billions of years, the sun's gravitational pull has slowed Mercury's rotation. However, unlike our moon, which is completely tidally locked to Earth, Mercury is in a 3:2 spin-orbit resonance, meaning it rotates 3 times for every 2 orbits around the sun. The effects of this unusual day-night cycle on Mercury's surface are extreme. The side facing the sun bakes under intense heat for months, while the night side remains in frigid darkness for an equally long period. This leads to some of the most extreme temperature variations in the solar system. Mercury's atmosphere, or rather its lack thereof, is worth noting. What little atmosphere Mercury has is called an exosphere, an incredibly thin layer of gases constantly being lost to space and replenished by various processes. The solar wind, radioactive decay, and micrometeorite impacts all contribute to maintaining Mercury's tenuous exosphere. Recent observations revealed surprising components in Mercury's exosphere. In 2020, researchers using messenger data discovered more water vapor than previously thought. This water vapor is believed to be created when hydrogen from the solar wind combines with oxygen in Mercury's surface rocks. Mercury's short year and long day also affect how we study the planet. Because Mercury orbits the sun so quickly, it's challenging for spacecraft to reach it. They need to use complex maneuvers, including multiple flybys of Venus and Mercury itself, to slow down enough to enter orbit around the planet. As we continue to explore Mercury, new questions arise. How does the planet's core remain partially liquid despite the long nights and extreme cold? What role does Mercury's unusual orbit play in shaping its geology? These questions remind us that even in our own solar system, many mysteries remain to be uncovered. Mercury's unique characteristics challenge our understanding of how planets form and evolve, pushing us to expand our theories and explore new possibilities. So, what other secrets might Mercury be hiding beneath its cratered surface? A small planet with too many intense secrets. Mercury, despite its size, packs a surprising number of mysteries. One of the most intriguing secrets is its unusually large core. Dr. Nancy Chabot, a planetary scientist, led a study revealing that Mercury's core makes up about 85% of the planet's volume, significantly larger than Earth's core, which accounts for only about 15%. One theory suggests that Mercury may have once been a larger planet that lost most of its outer layers in a massive collision early in the solar system's history. This hit-and-run scenario, proposed by Dr. Eric Asfog, suggests that a large planetesimal might have struck Mercury, stripping away much of its mantle and crust, leaving behind the iron-rich core we see today. Mercury's unexpected magnetic field is another mystery. Unlike Venus and Mars, which lack global magnetic fields, Mercury generates one about 1% as strong as Earth's. This surprised scientists, as they didn't expect such a small, slowly rotating planet to maintain a magnetic dynamo. Recent discoveries of volatile elements on Mercury's surface, such as sulfur, potassium, and sodium, also raise questions. These elements typically evaporate quickly at high temperatures, so finding them near the sun was unexpected. Some scientists propose they may have been delivered by comets or asteroids. One of the most exciting discoveries is the presence of water ice in permanently shadowed craters near its poles. The ice exists despite Mercury's proximity to the sun because these craters never receive direct sunlight, keeping temperatures extremely low. Moreover, evidence of organic compounds has also been found, potentially offering clues to the origins of life. As we look forward to future missions and discoveries, it's clear that Mercury, despite its small size and proximity to the Sun, still has many secrets to reveal.